All right, I'm always afraid somebody's going to keel over here with these bar
so
stools.
difficult.
We've got,
Yes. Closer.
two people jet lagged. Hugo's thinking about West Coast IPAs. So, yeah, who knows? Usually when I do these panels, and a lot of moderators say, these panelists don't need any introduction. I think in this case, usually they're lying, but in this case, I think that's true because you've all been on this stage just now. But for those who just came in, maybe missed the panel, can you just briefly introduce yourself?
Nelly Porter, Google.
That's it?
Hugo Romero, AMD.
Mike Bursell, Confidential Computing Consortium.
Najwa, Aaraj, GII.
Russinovich, Microsoft Azure.
All right, that's about the quickest introduction I've ever had at one of these. Usually somebody goes off for 5 minutes. My timer, by the way, says we only have 3 minutes left, so we can fix that at some point. Thank you. So in this panel, we want to talk a little bit where we are with sovereign AI at this point. And so maybe Hugo, you can start with this. We've talked a lot about CPUs and trusted enclaves. But when it comes to AI, we typically talk about, we have to talk about GPUs as well. So maybe we can start with that. Where are we right now when it comes to confidential computing and GPUs? Not just VMs, but GPUs, and I'll get to our other folks.
I think we're missing one representative of this topic on our panel to start this conversation.
Indeed, indeed.
Would you start?
He's sitting down there.
Hugo was going to say.
Yeah, Hugo, if you want to start.
Yeah, okay.
Absolutely.
Yeah, so where we are today is we have the standard for TDISP, right? So we have a TDISP, we have the ability for the CPU to connect with the GPU, right? So we have that, and that's something that's already deployed, right? And then it's something that is going to continue to provide that, and not only for GPUs but other endpoints. So that's something that's going on.
Mm-hmm. Mark, kind of how are you doing that in the cloud at this point? Like, how are you connecting your GPUs to this secure enclave? You've talked about it a little bit, but
Yeah, I mean, so we introduced. First, the A100 had preliminary support for confidential computing. We introduced that. Then H100s. Now we're looking at what's coming with Vera Rubin, which is very exciting, and MI455 from AMD. Also very exciting parts because that supports TDISP, both of them. It also supports protection over Infinity Fabric or NVLink. So you get this basically can scale confidential AI acceleration, not just from one GPU on a node, but to all the GPUs on the node, to now GPUs across a whole data center. And so that's the unlock for, if you take a look at inference, many of the models today consist of both CPU components as well as they're multimodal and support multiple different submodels that are executing on different GPUs. So you need that connectivity across devices and domains with confidentiality that now this accelerated hardware protocols give us. And then when you talk about training, of course, where you want to protect the model's IP while it's being trained and the data that goes into it, you need potentially scale of hundreds of thousands of GPUs. And so we're well on our way to getting there in the next year.
I think one of the interesting things from my point of view is that when we first started thinking about this, it's kind of a naive thing. We've got a CPU and we probably want to connect a GPU to it. And it's a lot more complex than that. As you've just said, you want to be able to have more than just the one GPU on that machine, and then it goes in that data center and then beyond. But there's also the sort of temporal question about, well, you're not going to put them all on in one go, right? You're going to be adding them at different times and then taking some out. And you need to be able to be sure that you've got a trust fabric that supports that, your attestation at the right times. You talked about deleting things early on and making sure that, as you remove a GPU, it's not going to have access to the right stuff. So there's how you build sort of a composite CPU, GPU things, I think is going to be one of the really important things that we build over the next few years.
Now that we've reached this age of agents as well, Najwa, you talked about that quite a bit. How has that complicated things for you?
Yeah, actually, so as an institute, we have been building multiple platforms that are based on agents, right? And the way I see and what we're trying to do actually in our agentic platforms, and you will see probably Dr. Shawki talking later about the GeoInt platform that we have developed. We have developed a scientific platform, and we are developing cybersecurity platforms that are based on agents. We are looking into it into a modular fashion. We are putting an architecture together where the main architecture is the harness. We are looking into the autonomous, we have the governance layer, we have the orchestration layer, and we are looking into the autonomous loops and the verification loops. And we are looking into the components that differ from one agentic platform to the other in order to standardize it. Because as you said, it's going to be quite complicated to look into it as different platforms at all time. At the same time, we are aware, and I personally see the same pattern as before, where you have software that's being deployed, and then security comes or confidentiality comes as a second thought. So we're trying to deploy those platforms, keeping in mind what is the control security that needs to be done, what are the policies that need to be imposed at the governance layer. What are the checks that you need to put? And then especially when you are running agents that are coming from outside that you didn't develop, that you didn't put the identity, how I'm going, if needed, how I'm going to sandbox them in order to release them if the decisions is verifiable or is verified from a security standpoint. Now the complication comes that, and Aaron mentioned that in the UAE itself, there is a mandate to move into 50% agentic workflows. And this will complicate things tremendously, right? From a cyber perspective, from a privacy perspective, and confidentiality perspective. And this is where we're trying to work with the regulators in order to say, okay, how are we going to impose, or how are we going to put together policies and regulations for confidential AI? Where are you going to use trusted execution environments? Where do you need software in order to check the workflows and to check the execution of those? Where are you going to have to sandbox agents before they go into the machine, and etc.?
Did you say 50% of workloads are supposed to be agentic as a mandate?
50%, yes. And I don't remember now the year, but yes, 50%. And this has happened almost 2 weeks ago when this became as a law in the country, yeah. So just imagine, we've been talking in the UAE about agents shops, agents boutiques, agents everything, and now we have to move 50% of the government workflows to an agentic, to be agentic, yes.
Yeah, and their security cannot be coming second, right?
And trust me, nobody is thinking about security. That's the problem. Yeah. So it's like you use 50% as agentic, and nobody is talking about security, privacy, confidentiality. We spoke about confidential GPUs. I think this is where now we're starting to think about we need confidential GPUs for some of the workflows that we're going to implement.
Well, Nelly, you're laughing. I know at Google you take security somewhat seriously, I think. But is that your experience as well when you talk to customers? Is that this confidential computing thing comes second, third, last?
Security, privacy is important topics for most of my customers. But again, because of velocity of and demand that they have from different places to deploy agents and trying to figure out how to deal with that. It's coming usually from CEOs, from board, from CISOs, and usually people on the ground, this, again, normal humans that need to do what they have to do, they absolutely understand how to, again, continue to protect the enterprise's secrets and workflows and bring more agentic AI to the place. So we all talk about, again, the areas of policies, but something we didn't probably talk too much about, something I want to bring to this conversation, is a policy augmented by humans would not work. And the reason why, because we honestly, as humans, have no idea what agents trying to reach out and what they need access to. It's why this identity and access permissions that we're so used to simply would not work. It's like VPN. When you add access to something, it's continuous, those agents will continue to access that. So you need to have human on the loop, not in the loop. Because when we have human saying yes to every single question that agents will say, it's not useful at all. So we need to have ability to put agents to be auditors when the elevation of privilege is happening, when those agents trying to access the secrets or perform some delete database operation, we need to have ability to validate justification why these runtime things need to happen and have some policy in place what allow or disallow in this matter. But it has to be agentic, it has to be scalable, and it has to be trustworthy. So it have to run in confidential environments anyway. But all of this policy gardening and the agentic and the ability to provide the scalable infrastructure with GPU, CPUs, networking, we forgot about networking, storage, all of this system, it's not a confidential TEs anymore, it's the whole entire confidential system. And it's what we need to start, continue to talk and continue to emphasize.
What is still missing in that system? What do we still need to build? And I know, Mark, you talked a little bit about what's coming next, but maybe you can tackle that.
Well, I think a lot of things need to be built still.
How far are we in this process?
Well, and I want to, so there's a couple things, I think, when you talk about specifically about agents, when we talk about governance, I think one of the requirements, which is kind of independent of confidential computing, is being able to have policies around what the agents can and cannot do, and to prevent against prompt injection attacks, as well as prevent execution of consequential actions without some approval, whether that's a human or another system. That's independent. And right now, we don't have those systems in place. Basically, it's human in the loop, just have the agent go do whatever. And if it's going to perform one of those things, a consequential operation, summarize my email, it has access to Teams. It can send a summary of that to whoever, including people that aren't authorized to see the contents of that email. Today, it's the agent decides to do that, human, go approve it. And based off of limited information and all the problems we have with that. So that's one problem that hasn't been fully addressed yet. And there's work that we're doing at Microsoft, and other people like Google are working on it too, to come up with a way to actually implement policy that controls and governs exactly what an agent can do. But the other one I think is interesting is identity aspect, which really hasn't been fully worked out yet. We've all talked about it. We all know what we need to do, but it's moving from, whether it's an agent or a piece of software, moving away from this concept of identity is something I assign, who it is, to what it is. And it's basically what we're calling workload-based identity. And that's what we're starting on this path, but there's a lot of work to do. But when you talk about an agent, not who the agent is, but what the agent is, that's what dictates what it's able to do and access. And that's only possible with confidential computing, actually measuring and attesting to what this thing is, including its code and configuration, and potentially even policies that allowed it to get to where it is through the supply chain, like we've talked about with the transparency service. All of those things define the what, which is, I think, going to eventually replace, for autonomous systems, humans will be who, software systems will be, and hardware systems will be what.
Yeah.
So on two things. Firstly, if you're interested in trusted workload identity, we have a special interest group in the Confidential Computing Consortium working on that, but hugely important. The second thing, that to both your points, actually, both Mark's and Nelly's points about the governance, we need a bottom turtle, right? And to make sure that in the end, something is making the decision. I have concerns about that being both human and AI. AI is because I don't believe that they're fully trustworthy, and we're not sure we know. I'm not sure we know enough about them to make them trustworthy yet. But on the other hand, humans are too slow, and also we have the EULA click-through problem, right? If I'm sent a thing saying, "Is it okay for this to do it?" and I'm not sure, I'll probably just say yes. And I'm not sure what to do about that. I think there's, as you say, still work to be done.
Yeah. Hugo, you are a hardware representative here. Is there like something you can do there?
Please help us
Hugo's
out.
problem, that's great.
Please help us
So
out.
I really want to just say, like, I gotta repeat, like, the foundation is there, like the hardware is there, and that's something that we have, because the technology is moving so fast, and I think if we didn't have that strong foundation, it would be in big trouble. So the strong foundation is there, and I think all these questions are going to be answered. And I think there's a lot of good thinking going on there. But I think really that's where we have strong footing, and I feel good about that part because AI is moving so fast, and we all have to be on board the ship, right?
Is it moving too fast for everybody to react when it comes to? Mark, you're saying yes.
Yeah.
Are we lagging behind in confidential computing?
I liken the phase that we're in with agentic security to late 1990s internet usage, which is, hey, we know that there's risks, but it doesn't seem like only bad things have happened, so it must not be that high, to the wake-up calls that we started getting that forced everybody to take internet security much more seriously. We're not there yet with agentic security.
Yeah. You were shaking. You were saying yes, Nelly.
Completely plus 100 to what Mark said. We not here again, and it will continue to evolve. We need to figure out how to make, and again, whatever Lego blocks we have to solve this puzzle and help, because we have opportunity to help. But it's still, again, exactly +1, identity, access, decision making. Humans are not, again, really equipped to do that in the time. That's absolutely shrinked for AI decisions. So we need to figure out how to entrust those agents to be the proper arbiters of those decisions. So the only what I will say, humans is who, agents is what, but all of us need to answer why. Why we need to get access to X, Y, Z, and what we will do with that.
There's one other thing I think I need to say, I think I'm contractually obliged to say as a part of the Linux Foundation, which is, yes, we've got the hardware foundation. We also need open source as part of the foundation. We need to have things we can look at, we can check, the community can be part of, the community can look at and know that what we're building on with that hardware allows us, everybody, to have something they can trust in. Without that, it's very difficult to build things, and that is part of what the Confidential Computing Consortium is there for. End of plug.
Sure. And I have no contract with the Linux Foundation, but the Linux Foundation did announce the agent name system today, the ANS, based on the DNS system to give agents identities. So there's all kinds of projects happening there as well, I think. One, maybe switching topics just a little bit. It's, when we're dealing with confidential computing right now, that also means we have to trust the vendors we're working with. And Najwa, you published an op-ed today in Fortune that I saw earlier today. And in that one you say, and I'm just quoting this here, no single cloud provider or model developer can be the sole authority on trust. Now we've got two cloud providers here, but maybe you can explain that a little bit, what you're saying there.
I think it goes back to what I was explaining before, right? Because today, if you look into how you're doing the training of your model, and I'm not talking about agents over here, I'm talking about the model training. You see, and we as an institute, we trained our model, we trained our LLMs, etc. And then all the information that we have used in order to train LLM is open source data. And what we try to get sensitive data, or when we try to get proprietary data, and in order to do the training, the first question we were asked is, are you using a hyperscaler infrastructure, or are you using in-country GPUs that are in an air-gapped environment? And whenever you say, okay, I am with a cloud provider where you are exposing your data in plain text and the rest, there is no trust guarantee that there is no leakage of data, there is no exfiltration of data, and like access to the data that you are training with. And I think that along the same token, you can talk about inference. When you are putting your prompt out there in plain text, or when you are including sensitive data in your inference, you cannot trust the hyperscaler, or you cannot trust the provider, regardless what they tell you about the key management system, regardless of what they tell you that you manage your own environment, etc. You cannot put your full trust in there. So this is from that aspect.
Sure. for our cloud providers. How do you feel about that?
We feel very strongly that we are not trying to be trustworthy. The goal for us is to prove and actually do not get our customers to believe that all of what we do is built on our contractual agreements. We want to ensure that we build this environment specifically and investing heavily in the trust infrastructure so that customers can verify every single claim that we are making about access to the data and, again, access to the workloads, environments, AI and not AI based. So I don't think cloud providers as, again, trying to become trustworthy. I know that it's contradiction, but I think we don't need that. To be successful and provide our services to our many, many, many customers, we should not ask them to trust us. We always ask them to verify what we do, and we're trying to provide cryptographic claims for them to do that. Mark?
Well, first, I think there are a lot of customers. We ask our customers to trust us.
You do?
And, you know,
Do they say you're
I mean,
trustworthy?
trust is earned, right? I think in general, trust is a complex equation. It doesn't come with a binary. And some of the ways that we earn customers' trust is through our track record. It's through the actions that we've performed, through the way that we've executed and protected their data and handled it. Another way that we earn customers' trust is with third-party auditing, and this is something that all the cloud providers have third parties that come and audit us. We also self-audit and make attestations, but we've got third parties, whether it's SOC or ISO or FedRAMP, that are coming in, auditors looking at us and evaluating the claims that we make, and then verifying and making statements. But where we all want to go, and I think this is for our own protection of our own data and our own supply chains and our own infrastructure and our own systems, as well as being able to make stronger claims to customers that they can independently cryptographically verify, like I talked about in the transparency section, is we want to move to a world where you can go get cryptographic verifiable evidence of the claims that we make. And that's a simple statement, very complex to actually achieve. So we're going to be on this journey for years to get to the point where you can say, this piece of code that's running in production, this is the way it's governed, and by the way, here's the way that it was created and built, and what policies determined that it could run and become a what that has access to my data. That is something that we're all building together, and the CCC plays a key role in us standardizing the way that we do that as well.
When it comes to all of this, it's not just trust, but also when I'm a nation state and I'm thinking about sovereign AI, I have maybe some different thoughts about that, because all of the big companies, the chip makers, they're all US based at this point, right? Do you get any pushback from that, where people say, well, especially now in Europe, and we live in a complicated world right now, it's hard to trust you right now, potentially.
By you mean US people, or?
Yes, not you. You're excluded. You're good.
I'm not saying that, right?
You're part of us. Don't even pretend.
You're British. You have pups.
Yes,
you're good.
Yes, you're good. Yes.
Okay.
No, but thinking about the clouds especially, but also kind of Hugo on the hardware side.
So sovereignty requirement becoming more and more critical for us to do business globally, and we global company, we have regions everywhere. And customers have different way to process the sovereignty requirements. So some of them need to have, again, more stronger confidentiality and integrity assurances in our cloud environments. We see that controls that guarantee data residency and our external key management when they have full control over cryptography that they use to protect their data. Some customers prefer to use our fully partner-operated environments in France and Germany, for example, where sovereignty requirements much stricter. Some customers absolutely don't want to use cloud, want, again, air-gapped and completely different. So I think the requirements are different depending on workload, depending on their risk tolerance. But we see that most of customers want to have control. They need to have transparency and resiliency. They want to ensure that whatever will happen, they continue to do business. And it's critically important for them across the board.
Mm-hmm.
If I may
Sure,
add actually
yes.
to what Nelly is saying, as you know, an entity that's not US based, and this is something that we felt during the crisis that we went through over the past few months. I think sovereignty comes at different layers, right? And you can achieve your sovereignty to an extent if you don't own the infrastructure and if you don't actually own the compute chip. And this is something that as a non-US entity, I can tell you that this is a problem that we face, right? So you can achieve your sovereignty by having your own models. You can achieve your sovereignty by having your own agentic platform. You can achieve your sovereignty to a very large extent by having your key management system, your cryptographic stack, etc. But there is still a dependency on the compute chips, and also on the infrastructure. And this is where today, the sovereignty layer stops, actually. And maybe to go back to your previous question, it's also very important for the hyperscalers, for the infrastructure providers, for the compute chip providers to establish this continuity of provisioning this in order to establish this trust loop with the big organization outside the US, right? Today, if, for example, I don't have access to the H200s or the B300s, I'm mostly stuck, right? Or on TPUs, when in the case of Google, I'm mostly stuck. And the reassurance of having this infrastructure available is something that will increase our trust in relying of the hyperscalers and the infrastructure providers.
To reflect on something that Mark said earlier, trust isn't binary, right? It's gradated, and people don't care about security; they care about risk. And digital sovereignty, whether it's national or personal, or organizational, is about managing risk. And confidential computing and associated technologies allow you to make different risk decisions. They change where the risk bits live. You're going to need to trust your cloud providers to some degree. You absolutely need to be able to trust your supply chain, your hardware supply chain. But we need also to remember that, you know, if the supply chain or the cloud providers were to just sort of fall over a bit and let the US government see stuff, the reputational damage to them would be enormous, and the risk that they're doing that is so low because of that. So we need to take all of this together. You know, these people take security and risk very, very seriously, and confidential computing is about helping to build that and allow us to reason about risk and mitigate risk as part of our discussions about sovereignty. Mm-hmm. And that absolutely applies to the supply chain as well.
Yeah.
Hugo.
Yeah.
Hugo, can I trust you?
You can trust me for sure. Yeah. So one of the things that we're also working on at AMD is we're building out what we call the silicon provenance. We're starting to build out that part where we're taking cryptographic measurements from the whole design cycle all the way to the fab, and that's something we're working with Mark to eventually we're going to give you that the whole provenance chain, and you can see where that chip was made and every single delta, what happened there. But again, like Mark said, I think you need to trust, but you need to verify. Mm-hmm. And other things that we're doing also working with Mark is we've done with OCP, we've done what we call OCP safe, where we actually, audit our code and we have third parties generate stuff, and we cryptographically sign that, so you can always go back and look and see, hey, look, this code was already audited, and you should feel better about our platform. So there's a lot of stuff we're doing there to provide that assurance.
Right. I can trust that it ran on the right chip, that it's got the right governance. Can I trust or can I verify that it ran in the right place as well, in the right geography? Like, where are we with that? And
there's work going on. I'm aware of some early standards around that. I know that the the cloud providers are also working on how that is. And I think that's going to continue to matter. I wish it didn't, but I think it will continue to matter because no security is perfect. And there's availability as well as confidentiality and integrity we need to aware, which is something the cloud providers can work on.
Mark, you want to?
Yeah, I mean, so first of all, a claim and a token that says this hardware is running in this data center is something where we can provide. Then it's trust us that we're telling you that this hardware is only authorized to say have this claim if it is actually in that right place. We're also thinking further than that to say the hardware itself can attest to where it's located based off of GPS or some other system that ideally is encrypted and has integrity so that you have a higher degree of trust. So, and this is kind of the whole wave of verifiability. It's kind of a line moving where it gets more and more sophisticated. We're able to verify more, and more customers, as the line moves, will demand more verification. And so this is a journey that we're going to be on across all these aspects of what can I verify? How can I verify it? And it starts with the most sensitive workloads and the customers more concerned with risk that go first. Nation states in their clouds, for example, and their workloads, whether it's intelligence or defense, some of the first because human life is at stake very directly, and the whole nation's security is at stake, to everybody following along behind that, basically.
Nelly, just to give you a chance to also,
you
said we also do that.
So in 2020, 6 years ago, we introduced what we call shielded VMs. Today, all GCP services running in shielded VMs. As part of our VTPM claims, we provide location where this actually VM running, and it's as usual attestations that you can receive from VTPM. You would be able to understand exactly where your workload is running. So it's absolutely in place and customers can get it. Again, the location matter, but probably not as much as workloads is spin up through huge workflows connected in between and through multiple data centers in multiple regions sometimes. So it's interesting to know that it's running right here in my house, but it's probably not sufficient.
All right, quick lightning round to end this. We meet again here next year. What do you hope we don't have to talk about anymore? And what do you hope we can talk about at that point? We'll just go down the line, and you've got 10 seconds because we're already over time.
Okay, so agents, how we will ensure that we will trust them a little more, and the most importantly, have control, deterministic control of crypto shred their memory.
Hugo?
I think I think we're going to talk about is all the new innovation of how we're trusting these agents, right? And what we're not going to talk about anymore is any overhead running confidential compute. It should be ubiquitous.
All right. Mike?
Open source, everywhere, transparent and expected. What we're talking about next year, open source everywhere, transparent and expected.
You just want to talk about open source.
I really do, yeah.
So I've already figured that out. Najwa?
Yeah, I think what I wouldn't want to talk about is, can I trust an agent that is running on my platform? And what I would like to talk about is standards for identity of agents or workloads.
Yeah, and I said this before, and Hugo kind of said it too. I hope that next year, that the next 12 months is the breakthrough where there's no excuse to not be confidential from a hardware capability perspective. And I think we're right there.
All right. I hope I don't have to talk about agents all next year, but that's a very different question. Thank you all very much. You were great panelists. Thank you.